Hello viewers, in today's session we are going to discuss another very important and conceptual problem from derivatives involving the absolute value function, which is also known as modulus function, right? So in this class we are again going to solve one important problem related to derivatives. So here we have a function f of x, which is given as a mod of secant 3x, and we have to find the value of this expression, that is e raised to greatest integer of f prime of x at x is equal to 5 pi by 12, right? So here we are given a function that is a mod function, the mod function of a trigonometric function, and then we have to find the derivative of this function at this point 5 pi by 12, and then with the help of the value of the derivative at this point, we'll calculate the value of e raised to greatest integer of f prime of x. So here we are going to use the definition of mod function and some important concepts from trigonometry. So let us start. So now let us first quickly see the sign convention of trigonometric functions in the four quadrants. So here we have the four quadrants. This is first, second, third, and fourth. So here we have 0, here we have pi by 2, here we have pi, here we have 3 pi by 2, and then we have 2 pi, right? So here we have f of x is equal to mod of 3x. Right now, see, in the first quadrant all the trigonometric functions are positive, and in the second quadrant only the sine and cosec functions are positive, and in the third quadrant only the tangent function and cotangent function, that is cot and tan function, are positive, and in the fourth quadrant only the cosine function and the secant function are positive, right? So now here we are given f of x is equal to mod of 3x. Now here let us see this term, that is 3x. Now we have to find the value of the derivative at this point, that is 5 pi by 12. So let us find out the value of 3x at this point. So we have 3 times 5 pi by 12. So this is 3 times 4, 12. So we have 5 pi by 4, that is 225 degrees, right? So we see that this angle, that is 3x, it lies in the third quadrant, right? And in the third quadrant the secant function is negative, because the tan function and cot function are positive, right? And the remaining four trigonometric functions are negative. So here this angle, that is 3x, this is our 3x, and 3x is equal to 225 degrees at this point, and this angle falls in the third quadrant. And in the third quadrant the secant function is negative, right? So 3x lies in the third quadrant, that is 3x is greater than pi, but it is less than 3 pi by 2. So the secant function is negative. Now let us quickly see the definition of mod function. Now see, a mod of p is defined as negative p when p is less than 0. So here we can also define mod p as positive p whenever p is greater than 0, and mod of p is 0 when p is 0. But here I will use only this part of the definition. So mod of p is negative p when p is less than 0. So now secant x, secant 3x is negative, that is it is less than 0 when x is 5 pi by 12. Or we can in other words we can say that 3x lies in the interval that is pi to 3 pi by 2. So mod of secant 3x is equal to negative of secant 3x when 3x belongs to the interval that is pi to 3 pi by 2. So remember here secant 3x is assumed to be p, right? So mod of p is equal to negative of p when p is less than 0. It means secant 3x is less than 0 when 3x belongs to the third quadrant, right? So now f of x is given by a negative secant of 3x. So now let us differentiate f of x with respect to x. So the derivative f prime of x is given by d by dx of negative of secant 3x, that is negative d by dx of secant 3x. Now from the standard results from derivatives, we know that the derivative of secant theta is given by secant theta tan theta. So here theta is 3x. So we have minus, then we have secant 3x, tan 3x, and by chain rule, the derivative of 3x. So the derivative of 3x is simply 3. So we have minus 3 secant 3x tan 3x. So the derivative, that is f prime of x, is given by this expression, that is minus 3 secant 3x tan 3x. So now let us write f prime of x as minus 3. Secant 3x can be written as 1 over cos 3x, and tan 3x can be written as sine 3x over cos 3x. So we have minus 3, and here we have sine 3x, and here we have cos square 3x. So this is another expression for the derivative of f of x. So now let us find out the value of the derivative at this point 5 pi by 12. So f prime of 5 pi by 12 is given by a minus 3 sine. We have 3 times 5 pi by 12, taking x is equal to 5 pi by 12, and then we have cos square 3 times 5 pi by 12. So here we have minus 3 sine, this is 3 times 4, this is 3 times 4, we have sine 5 pi by 4 divided by cos square 5 pi by 4. So now we have to find the value of sine 5 pi by 4 and cosine 5 pi by 4. So let us use some trigonometry to get the values of sine 5 pi by 4 and cos 5 pi by 4. So sine 5 pi by 4 is given by sine pi plus pi by 4. So we can split 5 pi by 4 as pi plus pi by 4, and similarly here we can write pi plus pi by 4. So here we have sine pi plus say theta, and here also we have cos pi plus theta, right, where theta is given by pi by 4. So sine pi plus theta is given by a minus sine theta, and similarly cos pi plus theta is given by minus cos theta. So here we have minus sine theta is pi by 4, and here we have minus cos pi by 4. So this is minus 1 over square root of 2, and here also we have minus 1 over square root of 2, because sine pi by 4 and cos pi by 4 are equal to 1 over square root of 2. So now f prime of 5 pi by 12 is given by minus 3, and sine 5 pi by 4 is given by minus 1 over square root of 2. And here we have cos square 5 pi by 4, so we have minus 1 over square root of 2 square, right? Okay, so now this is minus time minus plus, so we have 3 by root 2, and this is minus 1 over root 2 square, so we have here a 1 over 2, right? So this is 3 over root 2 times 2, and that is 6 over root 2. So we can now write 6 over root 2, rationalizing the numerator and denominator by square root of 2. We have 6 root 2 over 2, and this is 2 times 3, 6. So this is 3 root 2. So the value of the derivative of f of x at this point, that is 5 pi by 12, is given by 3 times square root of 2. So now our aim is to get the value of e raised to greatest integer of f prime of x at this point, that is 5 pi by 12. So we can now write e raised to the greatest integer of f prime of 5 pi by 12. F prime of 5 pi by 12 is 3 root 2. Now see, the value of 3 root 2 is given by 3 times. The approximate value of square root of 2 is 1.414, and if we multiply 3 and 1.414, we'll get 4.242, right? And the greatest integer of 3 root 2 is given by greatest integer of 4.242, and the greatest integer of 4.242 is 4, right? So the value of e raised to greatest integer of 3 root 2 is given by e raised to 4, right? So the value of this expression, that is e raised to greatest integer of f prime of 5 pi by 12, is equal to e raised to 4.